All right. Well, hello everyone, and good afternoon, and welcome to part 9 of the AI course presentations. This is during Unit 2, the history of artificial intelligence. And today we're going to specifically look at history as it relates to the modern era, which would be from 2010 right up to the present. Let's get started. All right, so we're going to start today with a history of the 2010s, fairly recent history. The 2000s saw machine learning as the dominant paradigm of AI research, and the explosion of the internet gave algorithms something they'd never had before: vast amounts of data to learn from. So researchers such as Yang Li-shun and Yoshua Bengio and Geoffrey Hinton, probably got one of those three names right, published numerous influential papers on deep learning during this period, which laid the foundation for modern deep learning algorithms. But as well, graphic processors, originally designed for high-end video games, were beginning to be recognized as very powerful tools that could accelerate neural network training. In the 2010s up to the 2020s, by the 2010s, internet users are starting to notice that if they search for something like a Chevy truck, then all of a sudden a lot of Chevy trucks would be showing up in their social media feeds. And autocomplete was being very helpful, but with typing and predicting the next word or the next thing that they wanted to say when they would do a search. AI tools were now quietly working in the background. By 2016, Google's DeepMind's AlphaGo defeated the world's top Go player, which traditional AI models struggled to play the game Go due to the variety of possible moves in the game. And researchers at the University of Alberta introduced DeepStack, which was an AI-powered poker machine that mastered gameplay and could operate on a standard laptop, making decisions within 3 seconds. By 2012, Canadian computer scientist Alex Chervisky and Gregory Hinton at the University of Toronto developed AlexNet, which was a convolutional neural network which utilized 8 layers and 650,000 artificial neurons in a deep neural network for image classification, and they won the ImageNet Supervision Challenge. This triggered a seismic shift as investment would flood into deep learning, and the approach rapidly swept through computer vision, speech recognition, natural language processing, and the modern AI era had effectively begun. So in addition to improving computer vision, computer speech would improve as well by 2013 using tools like Google's Word2Vec and Stanford University's GloVe, which laid the groundwork for those large language models, or those LLMs, like eventually ChatGPT, and the vector as part of this process. By 2016, Google's WaveNet revolutionized text to speech using those deep neural networks and synthesizing speech directly from raw audio waveforms, resulting in more natural sounding speech. This led to voice-driven assistants like Siri and Alexa and Google assistants that would shortly follow. By 2017, I can't say the name, an Indian computer scientist in Google's AI division introduced the idea of the transformer to the neural network architecture, and this was revolutionary. It allowed the AI to focus attention and way more important parts of a sentence or a prompt from the users. And this again became the foundation of using scalable transformers in the generative AI systems. To this day, this is still used. I mean, when we talk about ChatGPT, in the GPT part, the T stands for transformer. The GPT stands for generative pre-trained transformer. So the onset of the large language models and the generative AI models was possible due to the advances to this stage in AI architecture, the immense computing power brought on by the internet, the explosion of online digital content, the widespread adoption of more powerful graphics processing units, in the transformer model, with the new training tools and training data like TensorFlow and PyTorch and Hugging Face. These are specific AI built tools for the AI models. As well, Google introduced something originally called BERT, which released in 2018 and introduced deep bidirectional language comprehension, which allowed AI to understand words in context rather than words in isolation. This laid the foundation for more sophisticated reasoning in those large language systems. OpenAI released the first GPT model in 2018, demonstrating to the world the power of large-scale language pre-training. All right, so now we're getting into our very modern history from the 2020s right up to the present. So in the last few years. By the early 2020s, companies like OpenAI, the founder of ChatGPT, Anthropic, the founder of Claude, and Google, which eventually released Gemini, were building these modern AI tools. GPT-3 released in 2020, and it was trained on 175 billion parameters, far exceeding its predecessor, and created a real growing buzz during the pandemic by generating impressive human-like text. It was during this time that the world overall started to get introduced to what these AI tools could do. Also in 2020, Google's DeepMind, its AlphaFold, solved the protein folding problem. This proved that AI could tackle major scientific challenges that had stumped biologists for decades. The global pandemic of 2020 opened up awareness in the world, with everyone at home on their devices, that these new AI tools had arrived. They were available for use, and they would soon become global adopted tools. OpenAI released DALL-E in 2021, a text-to-image model capable of generating realistic images from natural language descriptions and prompts. And this immediately highlighted the major progress in multimodal AI. Then in late 2022, ChatGPT arrived and changed everything. Within 2 months of release, ChatGPT reached 100 million users. This is the fastest adoption of any app in history, and ignited widespread use of the generative AI in daily work and in public life. And now these tools and these companies are household names, and society and governments are rushing to catch up. AI has made some major strides in generating high quality video, and some LLM agents outperform humans in programming tasks. In 2023, the American FDA approved 223 AI-enabled medical devices, up from just 6 in 2015. And autonomous vehicle services like Waymo now provide over 150,000 rides per week. On the government side, the EU, the AI Act was approved in 2024, which was the world's first comprehensive legal framework for AI, setting those global standards around transparency, accountability, and the regulation of these high-risk systems. 2 Nobel Prizes in 2024 in AI has moved AI from a fringe curiosity to one of the central scientific and technological forces of our modern time. By all indications, the pace of change is still accelerating rather than slowing. After 7 decades of AI history, from the concept of artificial intelligence to it becoming a fixture in our daily lives, AI now is a leading technology leading us into the future. So terms we've come to see along this journey can be seen in this word cloud. Alan Turing's vision of a genetic algorithm with a machine having a mind like a child at birth, receiving education and other experiences to become what we would classify as intelligent, has really come to pass. The human brain is estimated to have around 86 billion neurons, with upwards of over 1,000 connections on each neuron to other neurons, or synapses. It's also estimated that ChatGPT, or GPT-4, has over 1.8 trillion parameters. Now, the term parameters used to mean a weighted connection or a biased value within the network. We've examined that in Unit 1 of this course, that a model learns and adjusts during training. And ChatGPT 4 has multi-layer perceptrons, or MLPs, in their transformer blocks. So we are still in a state of accelerating AI technology. Modern AI models like ChatGPT, Gemini, Claude, they're estimated to have been trained on over 45 terabytes of data. So let's get an idea of what that really means. So for comparison, if you took a photo every second for 8.5 years straight, every second taking a photo, not sleeping, not eating, just every second taking a photo for 8.5 years, you'd fill up approximately 1 terabyte of data with all those photos. So 1 terabyte is equivalent to 1,024 gigabytes. A gigabyte, 1 gigabyte, is 1,024 megabytes. But you could think of a gigabyte as representing something like a digital movie. 1 gigabyte can store an entire digital movie. A megabyte, which happens to be 1,024 kilobytes, you could think of a megabyte representing something like a photo or a digital song. That's 1 megabyte. A kilobyte is 1,024 bytes. So 1 kilobyte could represent like something like one email or one page of plain text. And 1 byte is 8 bits of data. So 1 byte could represent a single character, like the letter A, or a single number, like the number 124. And 1 bit, well, that's the smallest piece of data a computer can have. That is essentially a 1 or a 0, an on or an off, a positive or a negative. That's the smallest piece of data that's stored on a computer. So a bit moves up to 8, it becomes a byte. 1,024 of those bytes become a kilobyte. 1,024 of those kilobytes become a megabyte. 1,024 of those megabytes become a gigabyte. And 1,024 of those gigabytes becomes a terabyte. And remember, we're talking about AI models trained on 45 terabytes of data. So let's think about those common uses of AI, what we've led to now in our history. Things like automation, including factories, smart devices like self-driving cars, or home devices, thermostats, etc. To background logic, where web pages make recommendations like Netflix or Amazon making purchase recommendations, e-commerce, search engines, navigation apps suggesting new routes. Security, things like fraud detection on our credit cards, or face recognition software, or spam filters. Or health, image diagnosis, new drugs just being discovered, health simulations running. To businesses, to automating processes like filling orders or doing paperwork, predictive maintenance, preventing equipment from failure, data analysis and customer service, to generative content creation. So us getting AI to write text for us, to write code for us, to create images or audio or video, to chatbots, to having conversations with AI, inquiring about information, doing research, etc. This is now our common use of AI and how it is really infused through many aspects of what we see, not just the common using something like a ChatGPT online. The growth of usage of sites like ChatGPT, which is estimated to have between 7 and 800 million weekly users, and this data might be out of not current by the time this video is watched. Or Gemini, estimated at 450 million users. Or Claude, estimated at 18.9 million weekly users. The prompts that users are writing into these chatbots are approximately 3 billion combined prompts per day into those 3 sites alone. Prompts that will take the user input as what the AI interprets as tokens, or they tokenize your prompt. So what we write or say into the prompt, the tokens are the fundamental. So just like bits are the fundamental units for the computer, tokens are the fundamental units that AI models use to process your prompt. Tokens are essentially, well, you could think of them as words, but they're also pieces of word. AI doesn't process necessarily whole words or whole sentences. Instead, it takes what you put in as a prompt and breaks it down into smaller numerical units. For example, the word the, it might be 1 token, while the word engineering might be broken into 2 tokens. ENGI and NEERING. Well, that's all we're going to take a look at for today in our final look at the history of artificial intelligence. I hope you found it useful, and I hope you have a great day.